Good morning, everyone. So in this video, I want to show you how to identify the key features of a polynomial, okay, by using its graph. Okay, usually we give you're given a polynomial function, but this time around, okay, we have a graph instead, and you want to identify the key features, and I'm going to show you how to do that. And this is number 5 from the packet that I gave you in class. So I'm going to include the arrows right here at the end, okay? Then you're going to identify the first key feature is the degree. So the degree here is going to be, the degree it can be either odd or even. In this example, the degree is even. And the reason why the degree is even is because both arrows are pointing toward the same direction, okay? And so that's why it's even, the degree is even. What is the sign of a leading coefficient? The sign of a leading coefficient is negative, and the reason why the sign of a leading coefficient is negative is because the arrows on the right is pointed down. Because since it's even, both are pointed down. Okay, that's why the sign of a leading coefficient is negative. Okay, so if it was an odd function like the one below, okay, if you notice the arrows, it's an odd degree because the arrows are pointing toward opposite direction, and the sign of a leading coefficient here is negative. Why? The arrows on the right is pointed down, okay, for odd degree. Okay, so what is the end behavior? So when writing the end behavior, we need to consider the functions, the end, what is happening at the end of the polynomial for all the number on the left of 0, and the second part is to consider what is happening at the end of the function when you consider all the number on the right of 0, all the positive x values. So when describing the end behavior, we want to consider all the numbers on the left side of 0. So as x goes to negative infinity, comma, okay, what is happening at the ends on the left side? Okay, since the arrow is pointing down, we say that y goes to negative infinity. Okay, it makes sense. As x becomes more negative, the y value gets even more negative. And he explained because the degree is even and because also the sign of a leading coefficient is negative. So if you consider on the right side, you see here that as the x values goes to or approaches positive infinity, okay, that represent the positive x value, what is happening at the ends? So the y is approaching negative infinity. Because the arrow is pointing down, that's why I use negative infinity. If we're pointing up, I will use positive infinity. Okay, if the end were pointing up, I will use positive infinity. So what is the y-intercept? The y-intercept represents the point of intersection between the y-axis and the function. So the y-intercept is right here. Okay, and the coordinate of the y-intercept is 0, 18. And what are the zeros? The zeros are right here. This is 1, 0, and another. And because there's the polynomial, okay, or the parabola here, pass through it, cross over, okay, the x-intercept, we say that those x-intercept are single. There's no double here. There's no triple, okay? So here we have x equal to negative 3. And then you have the second x-intercept is x equal to positive 3. So we want to derive the factor form. How would you derive the factor form? You want to start with y equal to a, okay, times x minus 3. And then, so I'm going to use the opposite of x minus 3, which is x plus 3 here. And the opposite of positive 3, we have x minus 3, okay? So for some of you ask me, how do I get the factor form? All I have to do here, I need to rewrite it at the expression or the equation is equal to 0. I need to find a number to add to negative 3 to make it into a 0. So I have to add 3 on both sides for the first equation. And the next one is to minus 3 on both sides. Okay, and the new equation will have been x plus 3 equals 0. And the second one is x minus 3 equal to 0. So now, this is before we apply the zero product property, okay? So then the factor form is going to be then x plus 3, and the second factor form is going to be x minus 3. But I don't know what is a. So to find A, I'm going to use an order pair. I'm going to use another pair, a point over than the x-intercept. Do not use the x-intercept because everything will cancel out if you use the point for the x-intercept. Okay, we want to use another point. So do not use the x-intercept because you already use the x-intercept to derive the factor form. But you can pick any point on the line. Okay, so I'm going to use here the y-intercept, which is 0, 18. So wherever I see y, I'm going to plug in 18. Okay, and wherever I see x, I'm going to plug in 0. Again, leave a alone. That's what you're trying to find out. Okay, 0 here plus 3. And then you have 0 minus 3. So 18 equal to, so let's do some mental math. 3 times negative 3 is negative 9 times 9 is going to be a negative 9a. And the goal is to get a alone. So to get a alone here, what do you have to do? So this is 18 equal negative 9 times a. So you have to divide by negative 9 on both sides. And then you end up with negative 2 equal to a. So I know what a is equal to. So the factor form is going to be y equal negative 2 factor of x plus 3 times x minus 3. And this is the factor form. Okay, and we are done. Okay, so I'm going to stop the video here. Okay, so we have done actually identifying the degree, the sign of a leading coefficient, the end behaviors, okay, the y-intercept, the zeros, the factor form. When I come by the second video, I'm going to show you how to derive the standard form, the vertex form, and the domain and the range. And you have a vertex form here because the polynomial here is a parabola. The vertex form only exists for parabola. Okay, it doesn't exist for polynomial with higher degree. Okay, thank you for watching my video. Have a wonderful day. Bye bye.